So I'm going to give you some class time to either start your homework or continue your homework. That's my plan for today. Give you a chance to practice some more questions that are based on the textbook there. For this section, they're actually pretty good. So just recap what we did on Friday because it's been a while, right? This is probably my template, that the one that I like to use a lot. Determine if order matters. Use perms or comps. I'm going to tell you right away, passwords, arranging of any sort, you're going to be like specific positions that are being filled, perms. Hands of cards, teams, committees, any kind of grouping where order doesn't matter, you're using combinations. Determine the total possible arrangements, that's your NU. Favorable, that's your NA. Right? And then you state it like this. In the homework video, you probably saw me starting with this, and then I would branch off. I would be like, hey, let's do NU first, and then NA next, right? And then I've just put them together, and then we get our numbers there. So let's continue with that. Let's go 17. Page 17. Try that one. And I'm kind of like, my idea here is I will do some classics, and then you can use that to solve other questions that are like this. I wish I could give you just like a one size fits all, but it doesn't with this unit. Okay, so 17. In a contest, there are 3 letter tiles. Sorry, not 3. There are letter tiles spelling out the word Winnipegosis. The tiles are being turned upside down and shuffled. The contestant is then asked to rearrange the tiles, then turn them over. If the tiles spell the word Winnipegosis, the contestant wins 10,000 cash. Determine the probability of the contestant winning this prize. Okay. Well, remember, probability, no longer how many ways can this be done. It says probability. So I'll go probability of winning will be NA over NU. That's in a nutshell what we're going to look after here. Let's do NU first. And I like to go arrow, not equals. First, what's NU in this case? Any brave volunteer? Number of ways you can just arrange the word, isn't it? Right? So, and what do you think of when it's arranging a word with letters that repeat? We just talked about it. Hopefully it's on your study sheet. But you would count the letters. How many letters here? I'm just going to take this arrow here. 12 letters. You got to help me out here. How many? There are 3 I's. If I miss anything, you let me know. 2 N's. 2 S's. That's right. There you go. That's it. Pretty sure. Okay, so we know this. So that's where our NU comes in. So it's 12 factorial just in general, because there's 12 letters and you've got 12 slots in a sense, right? You're arranging the letters that are in there. And then you're going to go 3 factorial, 2 factorial, 2 factorial. Okay, so that would be your NU. And you don't need to show me how you do this by hand. When you're solving some sort of word problems, just use your calculator to do this. Okay, so maybe I'll simplify this a little bit. I'll just go 3 factorial is 6, right? Times 2 times 2. That would probably be helpful to just get rid of the factorial, so it'll save you tons of time. So let's go ahead and type this in. 12 factorial. You got to watch out though how you're going to divide. You have choices. If you want to do this all in one shot, make sure it's in brackets, right? So there it is. So it's 19 million, almost 20 million ways of arranging that word. Got it? What's NA? How many ways can you spell Winnipegosis exactly the way it is? Just one time. There's only one way to get it right. Okay. So in this case, NA is there's no work really. Only one way to get it right. Same with 649, right? If you want to win 649, you got to get it exact. You got to have all those numbers that they read out. Okay. So here it is. Probability is 1 over. This is probably one that you just want to leave as is and not turn it into a decimal. What if I asked you what are the odds of winning? Based on that, the odds of winning in this case would be, remember, if it says odds of whatever follows that event, that means it's win compared to not winning, right? That's what we're after here. And so it would be 1 compared to, I like to show this step. If you don't want to, that's fine. I'm going to take away 1 from the total. And so it's 19,958, 399. Okay, so those are the odds of winning. We're going to leave it at, we're going to leave B. You're going to be fine without it. And then I'm scanning. Still scanning. Yeah, now I'm going to pause a bit here and I'm going to ask you to work on textbook questions. So this is what I'm going to do. I'm going to put the textbook questions up on the board because you don't have yours with you. I don't want you to carry that heavy textbook. I see you with those bio or chemistry textbooks. I'm like, oh my goodness, those are heavy. I'm going to put it up there. You take a picture of it. I have a few extra paper copies that I can probably put out here. If you rather want your own paper copy, you can do that as well. And we'll see how it goes. It could be that you're sitting in class, you're like, seriously, I did my homework, I know what I'm doing. I am very happy that you chose to do the homework. But before moving on, I want to make sure we are all on the same page. So if you could take a picture of that, because I'm going to also show you the back side of this. So if you could take a picture of that, that'd be great. Can you read it if you zoom in on your phones? Yeah? It's not too small. Okay. And here's the back side of this. Let me just get this lined up here. Okay. There we go. That goes all the way to 9. And hold on. Let's get the 12 in there as well. All the way to 12. And I'll put the key up as well, right? That way, as you're working, you can tell right away whether or not you're doing okay. So you should be able to, with one picture, let me just put my pencil on here. You should be able to get all the entire key, well, at least up until 13. You want me to cover? Hold on, let me cover this up. It's gonna throw you off. How about this? Hold on. There. Can you read that on your screens? Yeah. It's a bit blurry in my opinion. But right. Let's give praise where praise is due. Who did all of the questions? Anybody did all of the questions? Half of it? Half? Some? Okay. So it's fair to say we all have something to do, right? So I'll give you a little bit of time to work on it. If you're really stuck on one, call me or save that question for me to do it with you on the board, okay? There are some blank pages in your booklet that I would like you to use for it. So you just find the first one, like page 21 is the first one shortly after what we've just done. So if you want to just make sure you write down the page number, it's page 321 in your textbook. Okay. That would be where I would do the homework right now. So see if you can do it. See if you can come up with, and you might be frustrated. You will do it. You'll be checking the answer. You'll be like, oh my goodness. I want you to go back and see why is it that I got this wrong? What could have been the issue here? Talk to your neighbor if you need to, right? Okay, so that's, yeah, you should. I feel sorry for my kids because they have to hear them all the time, the cheesy dad jokes. Anyways, page 17. Assume you want to graph this without a graphing calculator. How would you do that? Well, I notice this is in vertex form, which tells me if I look at these values, right, I know that the vertex is, what's the first number here? 1, right? Positive 1? It's positive 1. So it's opposite of what's in here. So I'm like, okay, I've got 1 point. Bingo, right? Vertex is done. That's definitely something you need for graphing purposes. The y-intercept. Can I use my calculator to do it? For sure. I'm going to do it by hand. So it's basically when x is equal to 0. So that's 2 times 0 minus 1 squared minus 9. If you did this with a graphing calculator, don't erase anything. Try to just squeeze this in if you can. So that's 2 times negative 1 squared minus 9. Negative 1 squared is just positive, right? Positive 1 times 2 is 2. So it's negative 7. So I have my second point right here. Second point. Point number 1, point number 2, point number 3, here it is. I'm going to box this in. Right? That's point number 2. Point 2. This is point number 1. And I would argue you need 3 points to graph this thing. Okay? So watch what I'm going to do here. I'm going to start with what I have. 1, negative 9. 1, negative 9 goes right there. That's the vertex. We know that this thing is pointing which way? Opening up. How do I know that? A is positive, right? That's why I'm trying to get you to think through this already, so you're not coming up with a graph that's completely wrong, right? You should be able to catch your mistakes as you're doing this. And then what's your second point? 0, 2. Let's put that. Oh, sorry. Why did I put 0, 2? Sorry, guys. Right? How's your teacher? He's okay, but he makes a lot of mistakes. All right, there you go. 0, negative 7. Okay. What's my third point? How can I find it? If we could fold this paper, I would actually fold it along the vertex. And where would this point land if you folded it? Right there, wouldn't it? And you're like, I don't see it. I don't see it. Axis of symmetry to the rescue. Okay, this is my axis of symmetry. This is where if you were to fold it along this line, you would replicate this leg on this side. Okay, so this is the AOS, and this is x is equal to 1. Would you agree with that? Where did I get that from? I got it right from the vertex coordinate. The x value of the vertex is the axis of symmetry. So count. From the center to the left leg, how many units did I go to the left to get to this point? 1. From the center to this, a unit to the right, that's my third point. Let me use a different color for it. I'm going to use a red pen for that one. Okay. Found this using AOS. Found that one using the AOS. I kind of folded it. Now I have 3 points. I can now graph it. You're like, what about the x-intercepts, Mr. Erickson? Remember, I'm doing this without a calculator, right? Technically, I will expect you to find the x-intercepts. So here you would just go with it and graph it as is, and you're done, okay? I want to have the x-intercepts on here, so let's review how to do that. X-intercepts, we're going to go y2 is equal to 0, second, trace, intersect. Did you already do that? I'm not sure. Let's go ahead and do that just to warm up for today. So if I asked you to do this without a graphing calculator, I would be okay with those 3 points. But because we have our TI, we're just going to go ahead and enter that. So y2 is equal to 0, 2. Do you remember how to type this in? Because sometimes students think they do, but they don't. A standard window works great in this case. I went zoom standard. Yeah, standard window works great. Second trace 5. Enter, enter, enter. So that's negative 1.120 followed by second trace 5. You want a shortcut? I'm going to tell you now because you've done this enough. Instead of, you can choose which line to travel on. You just go arrow up or down. So if I go arrow up, I'm jumping to the red line and then I'm just cutting across like this and then just hit enter 3 times there. If you want it a little faster, that's how you do it. These are my x-intercepts. So you have to say it though, use calculator, right? Use calculator for this one. But I think it's very helpful to know how to do this, to kind of visualize it without a calculator. Like, what could I do without a calculator? Because I don't want you to be too fixated on that. So negative 1.12 is right there. 1, 2, 3.12 is right there. So I'm just plotting them. And so I go back to the vertex. I go out a little bit and then I curve up. Just make sure it keeps opening up out. And I would have f of x to x minus 1. Graphing is probably, if you practice that, you should be able to ace it every single time. Okay. So that's what I wanted you to get to here. Let's go to page 18, the one that I called optional. After today, I would say I expect you to know how to do that one. Oh, I think I made my point, but I'll make it one more time. Look at the axis of symmetry, right? Travel to the right. It's 1, 2.12. It's 2.12 units this way. If you were to go to the left, 1, 2, and then there's 0.12, it's still always the same distance to either side, okay? And the reason I'm mentioning it, because when we do word problems, that's going to be huge. To find that third point, that's going to be huge. And we're going to use our axis of symmetry to do that, okay? All right, let's keep going. Page 18. I'll make a little note here. Let's graph it first. Can you type this in? I need you to type this in and find a good window for it. Remember, put the leading coefficient, put that in a bracket like this, -1/2, and then you continue. I'll let you graph it first before I do. See if your window, if you figure out your window. Go get your jackets. All right, so we have this. I'll hit graph, and I see left leg. I know. Did I type this in right? It should be pointing down. Oh, I see. I see what happened. You see what I see? That should be inside. Oh, it shouldn't even be there, sorry. There, let's see if that does the trick. There, hit graph again, but see what I mean? One wrong button you press and it can throw everything off. So I want you to know that can't be. Right? So now it's even worse. I can't see a thing. Right? But yeah. That works. Okay. It's probably better. But let's see here. I'm going to say A is negative. So this is expected. The vertex, I can tell it's going to be negative 1.75, negative 12.54. It's going to be a wide, right? Like all these things, it's just a bubble, right? I know that already without even going any further. So let's place this. That means that the vertex, watch here, negative x, negative 12.4, right? Somewhere in here. And now it's pointing downwards. So it's here, and I will never see it with this window. I don't know what you tried. Let's see if Zoom Fit helps me out here. Pretty good job. Zoom Fit does a pretty good job. Okay, So here's the subheading that I want you to write down now that we found our window. No x-intercepts. Okay, I want to highlight that as well in my notes. Okay, no x-intercepts. How am I supposed to graph this? Well, let's find everything else. So I'm going to find the y-intercept. You can't just say it's negative 12.54 because it's not in general form. I will tell you this, most of the time it's in general form, okay guys? After we're done vertex form, most of the time it is in general form, which means that that last digit, the number is going to be our y-intercept. But here we go. Second trace value, x is equal to 0. It's negative 14.07. Right? And I'm going to give me the keystrokes here. Second trace 1, x is equal to 0. I have 1 point. I've got another point, 2 points. You want 3 points. Right? So here's what I'm going to suggest we do. Third point. How would I do that? Watch this, let y2 equal to the y-intercept. That's my cheat for this scenario, which should help you. So I'm going to go y2 is equal to negative 14.07, and then I'm going to go second trace 5 for intersect. I don't know if my key showed you that, but I do change it from time to time, my strategy, okay? Let y2 equal to negative 14.07, second trace 5. 5 stands for intersect. So let's go ahead and do that. y2 is negative, not minus. If you ever put a number down that is the leading coefficient or just a number in general, you have to start with a negative, not a minus. Okay, so you put that in your y2 and hit graph. Okay. So what's happening here is you drew a horizontal line that goes through the y-intercept, and it gives you another point over here. That's the one we're interested in right here, the second one. Okay, so we're going to go second trace 5. I'm going to go over closer to that second one over here, because I already know that the first one is my y-intercept. I'm going to find a second one. Enter, 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 and that is x is negative 3.499, which is really 3.5. So third point is negative 3.5, negative 14.07. That's what you've just found. So I'm going to say point number 1, point number 2, and point number 3. Now you can graph it. Are there other ways? Yes, there are other ways. And maybe as we go along, I will show you maybe a different strategy that I've used. Anyways, you know that the action happens in quadrants 3 and 4, right? It's in the bottom underneath x-axis. So I'm going to focus on that. So watch what I'm going to do here. I'm going to use my ruler. This is my x-axis right here. This is the x, and then the y. It kind of slightly focuses more on quadrant 3. Okay. So that's what I would do. And I can just stay to 1, a scale of 1 on the x-axis for sure. So 1, 2, 3, 4, 5. I'm just going to go like that. That tells me that you're using a scale of 1, sorry. That's okay like that. I'm going to go by twos here though. Watch this. 2, 4, 6, 8, 10, 12, 14. Is that a good scale? I don't think that's a good scale. I'm going to use a different scale. I'm going to go by fives. Okay, so this is -5, -10, -15. So just like that, I changed the way I do things. Okay, and that's okay because you're doing it on paper. So let's plot -1.75, -12. That's right about there. And then 0, -14 is right about there. That's my y-intercept. And the other one is -3.5. So this is 3.5 is right about there. And you just make sure it lines up with your y-intercept. You're good? This one I basically came up with here. And then you just curve it like this. And then you just insert your equation. And there you have it. This is my third point right here. So in a sense, guys, these are kind of like replacing the x-intercepts that I used to find. Okay. Mr. Dirksen, could I have let y2 equal to -20 instead? -20 here. And then found these 2 points here along the -20? Absolutely. It probably would have given us a better idea of what the shape really looks like. But find 3 points. So I'll make a note under this graph here. So I'll say this. Note, you should include at least 3 points when graphing. Okay, so it's on you to find those 3. Any way you can do it is fine. And students always teach me something. So how was it? Oh yeah, a student once showed me this one here. Oh no, that one doesn't work. I won't show you that one because it could confuse you actually on that. -14.07. Let me just try something. I'll show you. I'll take the risk. Okay. If you on your calculator, once you've graphed, if you press second and then second graph, you're actually accessing a table of values. Okay. Notice this. It shows you like when x is equal to, let's say, -5. On our curve, we are at -17.82. And you can keep going up. Like if you keep going up, if you wanted x is -10, it's -46.57 on our graph on the blue curve, right? So that's if you want to use these points to help you out, that's also something you can always access. And you're like, what's up with the red? Why is it always the same? Well, that's your horizontal line, right? So ignore that one. You just want the blue curve, like the parabola. Okay. So you can access this as well if you want to find more points. That's up to you. All right, let's keep going. I'm gonna